thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello everyone. Thank you for joining us for week 37 of the Oxygen Talk, brought to you by the Oxygen Alliance. My name is Sharon Bozo and I'm currently in Lilongwe, Malawi, and I'm pleased to be hosting the call today. Today I've been joined by my colleague, Maui Lungu, Cynthia Chikomoni, alongside our usual technicians from OpenO2 and Sunlight. On our technicians panel today, we have Masofa Mujaji, Kowinda Singh, Paulina Mohoto, Linda Mission, Francis Sambani, Fatsani Tamandikani, Kevin Saidi, and Naomi Thompson. So in case you're just joining us, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 Central African Time. And here we talk about different aspects concerning oxygen concentrator assessment, maintenance, or use. So if you have any questions concerning oxygen concentrator assessment or maintenance, we always advise you to send the question in advance to us via our email info@oxygenalliance.org, and our technicians will do their best to help you with the best solutions. So if you have any questions for us during the call concerning any questions that we'll be discussing, you be free to paste the question in the chat, or you can raise your hand and you'll be able to ask your question. So as usual, we also have a topic of interest today, and today's topic of interest, Kevin will be talking about different types of oxygen sensors. So now to jump into our questions. The first question says, hello, I'm an electrician who works in the hospital maintenance division at Chicago District Hospital. Someday during our weekly inspection of machines in the ward, we found a lot of working machines plugged in one extension. Two of the machines were oxygen concentrators. What impact may this have on the oxygen concentrators? I wondered. I'll ask Gowinda to answer this question.
Thank you, Sharon. Generally, oxygen concentrators mainly are not recommended to be used on the extension cords. They are recommended directly to be used on the ball ports. So this scenario will lead to a condition called overloading. Overload is an abnormal situation during which the current drawn by the load exceeds the current that can be supplied by the source. During overload, when the overload draws current and the current being drawn is more than the desired value by the extension cord, this leads to flow of excessive current in the circuit. This eventually can burn the extension cord or even damage the internal wiring of the building or the load when the extension fails to operate. So plugging into many machines in one extension that is not designed to carry increases the risk of a short circuit as the wire heats up so much due to the increased current, which causes the insulation to melt and eventually the wires come into contact. This short circuit can sometimes damage the machines, and also if they are not well protected internally. Therefore, do not use extension cords with oxygen concentrators or connect too many plugs into the same electrical outlet. Too many plugs into one outlet can result in an overload to the electrical panel, causing the breaker or the fuse to activate or fire if the breaker or fuse fails to operate. Thank you.
Thank you very much, Gowinda, for that explanation. Any additional comments from the audience or questions? Okay, if we have no further questions, we move on to our next question. And it says, hello, I'm a biomedical technician at Chitiba District Hospital. We have two oxygen concentrators that do not have flow meters, but the demand of the oxygen concentrators is very high at our hospital. Can we still use the oxygen concentrators without the flow meters? And what is the other alternative if flow meters are not available? I'll ask Paulina to answer this question.
Thank you, Sharon, for the question. Every oxygen concentrator is designed to have a flow meter that measures the rate at which oxygen gas flows from the oxygen concentrator to the patient as prescribed by the medical personnel. There are different types of flow meters, and these include a differential pressure flow meter that uses an orifice plate, nozzle, or tubes to measure loss as gases pass from one end to another. Ultrasonic flow meters that use a transmitter to send ultrasonic waves into a pipe and back to another sensor. The frequency of the waves is affected by the movement of the fluid within the pipe, which can allow the flow rate to be determined. Coriolis flow meters. The meter works via a vibrating tube, changes in vibration frequency, thus allowing an accurate flow measurement. Thermal flow meters use heat to measure flow rate. Temperature sensors located on the outside of the meter track the temperature of the gas as it flows through the tube or pipe. Electromagnetic flow meters use magnetic coils to create a magnetic field, which changes as fluids or gases pass through a pipe. These are best used for gases and liquids that can conduct electricity. Floating element flow meters use a float encased in a pipe. The float moves up and down as fluids or liquids are forced inside the tube, generating differential pressure. So if you look on the screen, that's a flow meter that's a floating element flow meter, which is mostly used in oxygen concentrators. So oxygen concentrator mostly use floating element flow meters that have a ball inside, as shown in the picture on screen. Oxygen provided by a concentrator is measured in LPM, which means liters per minute, for continuous flow. Some oxygen concentrators have a single flow meter, while others have dual flow meters. The flow meter can be adjusted depending on how much has been prescribed for the patient. So using an oxygen concentrator without a flow meter is not a good idea, because you will not be able to know how much oxygen is being delivered to the patient. You might be giving the patient less oxygen or more than enough oxygen, therefore harming the patient. The alternative is to get a flow meter from an old or dead oxygen concentrator if you happen to have the same model as the concentrator that you want to use on the patient. Replace the malfunctioning flow meter so that your oxygen concentrators can have flow meters. Make sure that after you have replaced the flow meter, there is no leakage on places like the knob, as this might affect the oxygen purity. You can use a soapy water solution to see if the flow meter has been tightened well. If the bubbles are not seen, then it means there are no leaks. It is important to note that different flow meters come with different flow rates. Most oxygen concentrator flow meters come in 5 liters, 10 liters, or 15 liters per minute. It should also be noted that some flow meters designed for a different concentrator model but with the same flow rate may not be interchangeable, because there may be differences in pressure that which they were calibrated. It might be possible to use a flow meter from a different model only if the flow meter have the same flow rating and are calibrated at the same pressure. Thank you. Sharon.
Thank you very much, Paulina, for that well detailed explanation. Any other additional comments from the technicians or questions from the audience? We have a hand from Fatan. Go ahead.
Right, I have a question. So you have explained about different types of flow meters. And my question is, can you use one type of flow meter in place of the other? For example, if you have a daily floating bore flow meter and then you replace it with an electromagnetic flow meter, would that work? Thank you.
Fatani, I didn't quite get the question. Can you please repeat that?
All right. I'm saying, is it possible to use one type of flow meter in place of the other? For example, let's say I have an oxygen concentrator with a dead floating bore flow meter, and then I find an electromagnetic flow meter and use it in place of the floating bore flow meter. Can that work? Can I replace one type of flow meter in another type of flow meter, for example? Would that work? That's my question.
Oh, okay, Fatani. It is always best to use the same type of flow meter that you find in a concentrator. So if you find the one with a floating ball, I recommend that you use a floating ball instead of an electromatic, only because of the calibrations and all of it. So I think it would be best to use the same one that you got on the
Thank you very much, Paulina. I guess, Fatani, your question has been answered.
Yes.
Thank you. Okay, so we have a poll at the end of this question. I'll ask Maui to launch the poll.
Thank you, Sharon. All right, so I'm launching our first poll of the day. So the poll says, have you ever replaced a broken flow meter with a well-functioning flow meter that was taken from another concentrator of the same model? I can confirm that I have ever done this before. Back in the days when we started the OpenO2 work, we still had issues with finding spare parts. So flow meters were one of the things we used to struggle with a lot. So what we would do is, if we find a concentrator that maybe has a broken compressor or needs zeolite, but then we don't have it at that particular time, we would get the flow meter from that machine and then replace it on the machine that is probably just missing the flow meter. So that helped us to at least get one working concentrator out of two working concentrators. So our votes are in, and it seems all of us have ever done this before, so which is a good thing. All right, so I'll be ending the poll now, and back to you, Sharon.
Thank you very much, Maui. So now we'll move on to our next question, and it says, hi, what effects can block-in flapper valves have on the performance of a compressor in an oxygen concentrator? I'll ask Francis to answer this question.
Thank you, Sharon. So, flapper valves are also known as reed valves, and you find them in a compressor. So, yeah, in the compressors of most oxygen concentrators, you find flapper valves, and where you find them is on the valve plate. So, just like any other valves, the reed valves open to give an air passage into the sleeve of the compressor or out of the compressor. They also close to prevent air from escaping. So flapper valves are also referred to as one-way valves because they allow air to flow only in one direction, that is into the cylinder sleeve or maybe or from the cylinder sleeve. Concentrators use the double wobble compressor, well, some concentrators do, which have two valve plates, one on each side of the compressor. So the valve plates have two reed valves each, one on each side. So that is one on the top and one on the bottom. So each valve closes a hole that goes through the valve plate. So what happens inside the compressor is that when the piston rod moves downwards, it creates a negative pressure, and as it creates that negative pressure, it sucks air from the outside since it's sealed. Like you have the piston cap pushing against the cylinder sleeve. So it creates that negative pressure, and then you have the air from the outside coming inside the cylinder sleeve or our compression chamber. In this case, we refer to the space inside the cylinder sleeve as the compression chamber. So there's now that air inside that compression chamber, and as the piston goes up, it won't go through the other flubber valve, the one that was used to suck air from the outside to the inside, because that reed valve is on the bottom. So as the piston goes up, it pushes against that reed valve, closing it. So the air now is supposed to go through the other reed valve. So as it goes through the other reed valve, the air now can go to maybe the seatbelts and all that. So this process repeats itself more like 60 times a second if you're in a 60 hertz, if you're using a 60 hertz power outlet, or 50 times a second if you're using a 50 hertz power outlet. So the reed valves are useful in the suction and discharge of air. If they are broken or faulty, then the whole process will be affected. There will be a leakage of air in the compressor, which will result in inadequate pressure from the compressor. Remember that compressors produce pressurized air, which is essential in oxygen production in the beds. Any decrease in the pressure being delivered to the beds might end up affecting your PSA process, which will eventually result in low oxygen purity. So for you to solve this problem, you need to be mindful every time you're servicing the compressor. Check the reed valves if they're in perfect condition. If one is broken, replace it with a new one. So you won't maybe find a broken lead valve, but the reed valve should sit perfectly flat on the surface of the valve plate. If you find out that it is curved, um, it shows that it's not sitting flat and it won't close tightly when air is trying to push against it. So it will be leaking and losing some air. So a more detailed on how this works can be found in one of our topic of interest which we did some time back on the double wobble compressor and how it works. So the link will be pasted in the chat for those on the call, and if you're watching the recorded version, you can find the video on our Oxygen Alliance website under the Concentrator topic of interest section. Thank you, and back to you, Sharon.
Thank you very much, Francis. I hope that helps with the problem you had with rubber valves. Just a reminder for those who are just joining us, please do share with us your contact details in the chat so that we can add you to our emailing list. So any questions or comments on the flapper valve question? If we have no question, we move on to our next question, and it says, hello, I'm a biomedical technician working on a 5-liter air-safe oxygen concentrator. The flow meter of this concentrator keeps on fluctuating and doesn't settle on a constant position. What could be the problem and how can I solve it? I'll ask Fatani to answer this question.
Thank you, Sharon. So a flow meter, which is sometimes known as a flow sensor, is a device that measures volumetric flow rates to determine how much liquid, gas, or vapor is moving through a pipe or conduit. In the case of oxygen concentrators, a flow meter measures the volume of the oxygen that is given to the patient. The unit of this measure is liters per minute. Now, a flow meter consists of a glass tubing, which is marked with numbers representing the flow, and also a floating ball inside, which is called a bobbin. As the valve of the flow meter is open, the bobbin moves up the flow meter, and the flow of oxygen is read from the position of the top of the bobbin or the middle of the bobbin. Now, there are a lot of factors that can lead to a fluctuating flow meter bore, including the leakage in the flow meter or another tubing in the concentrator. But the most common reason for that is incorrect delivery pressure set on the pressure regulator. Delivery pressure refers to the pressure at which the oxygen is delivered to the patient. This pressure varies across different models of oxygen concentrators. For the 5-liter air-safe elite oxygen concentrator, the delivery pressure is 58 kilopascals, while the 10-liter air safe, the delivery pressure is 138 kilopascals. Now, to solve your issue, you need to adjust your delivery pressure so that it is at 58 kilopascals. You can have a tolerance of plus or minus 3 kilopascals. You can adjust the delivery pressure using the pressure regulator that is attached to the product tank in an air-safe 5-liter concentrator. To do that, you need to follow these steps. The first thing you have to do is to locate the pressure regulator in your oxygen concentrator. In most concentrators, including the air-safe 5-liter, the pressure regulator is attached to the product tank, as you can see in the graphics. So in the graphics there, it's showing 2 pressure regulators. The first pressure regulator to your left is the medical air pressure regulator. That is the air that is coming directly from the compressor and purified air. So that is for regulating the pressure from for that air. And the second pressure regulator is attached to the product tank of the concentrator, and it is the oxygen pressure regulator. And this is the one that you have to adjust. Now, to adjust the regulator, you have to pull the adjusting knob of the pressure regulator and turn it anti-clockwise to reduce the pressure, or clockwise to increase the pressure. In order to adjust pressure for the 5-liter models of the air-safe, you open the flow meter all the way up to the maximum and then adjust the pressure regulator till the flow meter bore settles on the 5-liter per minute mark on the flow meter. After adjusting the regulator, the pressure should be around 58 kilopascals, and you can use any measuring device, any pressure measuring device to just verify the pressure. You can use a pressure gauge, or if you have a 2-in-1 oxygen analyzer that measures the pressure or the purity, you can also use that one as shown in the graphics. Now, when making the adjustments to the patient outlet pressure, you need to disconnect the pressure measuring tool and reconnect it every time you make an adjustment so that you can see the new pressure. And when the pressure is at 58 kPa, you need to push back the adjustment knob into place and check your flow meter, and you see that the flow meter bore will no longer fluctuate. It is also important to take note that it is completely normal for the flow meter bore to fall to 0 during a pressure test. Thank you, Sharon.
Thank you very much, Fatani, for that detailed explanation. So any comments from the technicians or questions from the audience? Okay, so we have a poll at the end of this question. I'll ask Maui to answer the poll.
Thank you very much, Sharon. So I will be launching our next poll. So the poll says, have you ever experienced a fluctuating flow meter bore problem? So I will give it a few seconds for people to vote, and then we'll have a look at the results. So this is a very common problem if most of the times I should say, if you rarely check for the flow meters, since the wires are connected inside, so you have to take it apart. So sometimes we get to ignore this part, but then it's one of the crucial parts, because any small leakage that you get here, then will give you these fluctuations. So it's always important to check this. And as Fatsani explained about the pressure regulator, sometimes these things begin to fail, and then as they weaken, it starts affecting your pressure. So it's always important to make sure that we are supplying the right flow of air to the patient, and we can only do that if we are very sure that our flow meter is producing what we need. So our votes are in, and it seems most of us have experienced this problem. It would be very interesting to just hear what problems the others faced and how they got around them. So maybe Sharon, if we can open it up to the audience, just so we also get to learn from them the problem they had and how they managed to fix their fluctuating flow meter. All right, I'll throw it back to you.
All right. All right. Thank you very much, Maui. So, for those that have ever experienced this problem before, maybe would like you to share with us what the problem was and how you sorted it out. Anyone?
Looks like we have a shy audience.
Sometimes it can be due to uneven. Hello,
Go ahead.
hello. So sometimes it can be due to uneven pressure on the seabeds, on both the seabeds. Sometimes it can be due to leakage also. That is also earlier mentioned by Patani. Yeah, thank you.
Thank you very much, Goinda. So he was explaining about the pressure in the seabed. So if you have the difference of that pressure, you can have the problem of the fluctuations. Anybody else would like to share? Francis?
So I think sometimes the problem can also arise because of, let's say for example in basic models you have like two one-way valves, one from this seabed and the other from this seabed. So what if one of those one-way valves is like broken? That means in that it is letting air flowing from the other direction, which normally it shouldn't. So yeah, that can also cause that problem of fluctuating flow because you have some air leaking going in a direction where it's not supposed to go. Yeah, that's all.
Thank you very much, Francis, for sharing your experience. Okay, so now we move on to our next question. And it says, I'm a nurse at a certain health center. I work in the pediatric ward. We do not have enough concentrators in the ward, so we usually use oxygen flow splitters for us to be able to administer oxygen therapy to more than one baby using one concentrator. Earlier this week, we had a problem with one of the flow splitters. The problem was that water from the humidifier bottle had entered the flow meter on the oxygen flow splitters, and we were unable to adjust them. This is the second time we are having this kind of problem. How can we prevent this problem from reoccurring? I'll ask Linda to answer this question.
Thank you, Sharon. Oxygen flow splitters are one of the important accessories used with oxygen concentrators or oxygen cylinders. And oxygen flow splitters allow the delivery of oxygen therapy to multiple patients using one oxygen concentrator while independently monitoring and adjusting each flow rate. And the oxygen flow splitters, which are most commonly used, have flow meters with flow rate ranges of 0.1 liters per minute to 0.2 liters per minute. As such, they are commonly used to deliver oxygen therapy to children. According to World Health Organization guidelines for humidification, when delivering oxygen therapy using nasal prongs or catheters to children of under 5 years of age at low flow rates of up to 2 liters, humidification is not required. However, in some cases, humidification may be required even at low oxygen flow rates, depending on the doctor's prescription for the oxygen therapy. When using just an oxygen concentrator, it is easy for the medical personnel to attach the humidifier bottle to the concentrator, unlike when using oxygen flow splitters. Use of oxygen flow splitters require some expertise for one to be able to set up the splitter correctly and deliver the prescribed oxygen to the patient without making any mistakes. So usually water from the humidifier bottle accumulates in the flow meter of the flow splitters when the humidifier bottle is connected between the concentrator outlet fitting and the inlet port of the oxygen flow splitter, which is an incorrect way of connecting the humidifier bottle to the splitter. So when humidification is required while using oxygen flow splitters, the humidifier bottle should be connected between the outlet of the splitter and the patient's tubing, and make sure that the water in the bottle should not exceed the maximum level marking. With this connection, you'll be able to prevent this problem from recurring. So as we can see in the graphics, the image just shows the correct connection of the humidifier bottles to the flow splitters. So I would also recommend that you approach maintenance personnel or any other person who is conversant with the proper handling of oxygen flow splitters to train all the users of the splitters in your ward. Thank you. Back to you, Sharon.
Thank you very much, Linda, for that explanation. I hope that helps with the flow spreader problem. Any comments from the technicians or questions? Okay. If we have no question, so we have a poll at the end of this question. I'll ask Maui to launch the poll.
Thank you once again, Sharon. So I have launched the poll, and the poll says, have you ever come across a flow splitter with water inside? So I have ever come across this once, and mostly I see that it's an issue of some people don't really know how well to use the flow splitters. So I think it's something that the users of the concentrators, the nurses and the doctors, need to be trained on all the time. And it's us, it's the duty of us as biomedical engineers to train these people on how best to use the flow splitters. So it seems most of us have never experienced this problem before. Okay. This is interesting. So I guess now we are prepared on how best to solve this issue or how to prevent it as well. So thank you very much, Linda, for that explanation. I think it has helped us a lot here. Back to you, Sharon.
Thank you very much, Maui. So reaching this far, we'll take a slight diversion to today's topic of interest. So as I already pointed out, Kevin will be talking about the types of oxygen sensors. So over to you, Kevin.
Thank you, Sharon. As Sharon has already said, in today's topic of interest, we'll be talking about oxygen sensors. And as you are all aware, I believe, oxygen concentrators are machines that purify ambient air by filtering out the nitrogen, and they deliver oxygen-rich air to the patient. And in order to ensure that this system is always providing high purity oxygen, we need a mechanism that monitors this oxygen concentration. This mechanism will help us in alerting the user if the concentration of oxygen drops below a certain threshold. And according to WHO, this threshold is 82%. So monitoring of this oxygen concentration is done by an electrical device called an oxygen sensor. And this oxygen sensor measures the proportion of oxygen gas in a particular fluid. So these sensors, usually they are either fitted inside the oxygen concentrators or are built into handheld oxygen analyzers. So one can ask, why are we having oxygen sensors inside the concentrators while you also have oxygen analyzers? At times, the sensors in oxygen concentrators, they fail, and it can lead to false readings. So we need those oxygen analyzers. And you can define an oxygen analyzer as a device that is used to measure the concentration of oxygen in a given environment. And in our case, the environment will be the oxygen that is coming out of the concentrator. So as you can see from the graphics, we have the two types of oxygen analyzers that we have at our Open O2 training center. As you can see, oxygen analyzers are very important tools, and they are used for troubleshooting oxygen concentrators. And I recommend any workshop that works on oxygen concentrators to have this device. And if you cannot afford to purchase one, you can build one of your own. And if this is the approach you are going to take, an obvious factor you have to consider is the type of oxygen sensor you have to use. In one of our previous topics of interest, we shared how we can assemble a handheld analyzer designed by OpenO2, and you can find that on the Oxygen Alliance website. So these oxygen analyzers do use different types of oxygen sensors to operate, and today we'll discuss these types of sensors, their advantages and their disadvantages, if any. So the way you classify oxygen sensors is according to their mode of operation, and there are various ways of measuring oxygen concentration. Some of them are the electrochemical method, the optical method, the ultrasonic method, and laser methods. So moving on to electrochemical sensors, they are also known as galvanic sensors, and the way they measure oxygen is that they monitor a chemical process taking place inside the sensor, and it generates an electrical output that is proportional to the amount of oxygen present. And an example is the AP0001, as shown in the graphics. So the the basic makeup of this sensor is a cathode, an anode, and an electrolyte. So oxygen reaches the cathode and it undergoes a reduction process where hydroxide ions are produced. And these ions are passed through the electrolyte to the anode, where they undergo an oxidation process, which produces a metal oxide and some electrons. And these reactions, they create electric current, and the magnitude of this current depends on the amount of oxygen that was available at the cathode. Therefore, you can determine the concentration of oxygen in a particular gas by seeing the amount of voltage that is produced. Electrochemical sensors have different models, and they require calibration before use. This is because due to different models of these sensors, the output voltages differ. So if you want to calibrate one, say for example, you are calibrating a sensor at ambient air, you have to multiply the voltage it is giving out by a conversion factor, which is equal to the concentration of oxygen in the environment you are doing your calibration. In our case, so it would be maybe 20.95%. So the answer you get there, you multiply by the answer you get there will be multiplied by the voltage output of this sensor at different environments, and you get the percentage of oxygen in that environment. Electrochemical sensors have some advantages, and the first advantage is their low power. They are low power to operate, and this makes them very energy efficient. And they are less directly affected by other interfering gases. So this is also a good thing. They have a rugged design, which makes them very durable. There are two main disadvantages of these electrochemical sensors. And the first one is that they rely on temperature. They rely on temperature very much. So the process that I explained earlier, the reduction and the oxidation process is temperature dependent. And so if you have varying temperatures, this sensor, it also misbehaves. So you can get inaccurate readings at some point. And according to the sensor design, the chemical reaction will slow down eventually, and it will require constant calibration, and it has a shorter lifespan. So that's another disadvantage of electrochemical sensors. Moving on, we'll talk about the ultrasonic oxygen sensor. So these sensors, the way they work, they measure the gas's oxygen content using the speed of sound. This is because as the gas's density changes and the speed of sound also changes. So as you can see from the graphics, that's how an ultrasonic sensor looks. The transparent sensor is the ultrasonic sensor found on the Vubis 525 board. So the makeup of this ultrasonic sensor, it has two transducers that are contained in a tube to make up the ultrasonic to make up this sensor. So this tube has an outlet and an inlet, which allows gas to flow from the product tank to the to the to the flow meters in an oxygen concentrator. So this gas which goes in the inlet and goes to the outlet is mostly oxygen and nitrogen. So in order to sense oxygen, a sonic wave is generated by one of the transducers and it is transmitted to the other transducer, which transforms this sonic wave into a voltage corresponding to the magnitude of the wave, to the speed of the wave. So the speed will vary. The speed of sound varies in these two types of gases. In oxygen, the speed of sound is 332 meters per second, and in nitrogen, it's 354 meters per second. So the time taken for the sonic wave to reach the other transducer is used to determine the oxygen concentration. So the advantages of ultrasonic sensors is that they are more reliable than the electrochemical sensors. They are more stable. They also produce measurements with a high degree of accuracy. They are also long-lasting, and they can measure both flow and concentration simultaneously. So you don't have to buy a flow sensor. You can have one ultrasonic sensor and use to measure concentration and flow at the same time. The primary drawbacks are that ultrasonic sensors are affected by moisture, and they also have a flow limit of 10 liters per minute. And when you exceed this limit, you get very inaccurate readings, or unreliable readings, I should say. Now let's go to the optical sensor. And the concept behind an optical sensor is the oxygen-induced quenching of fluorescence. So they rely on a photosensitive material that will respond to light. They have a light source and a light detector. So oxygen has a tendency to absorb light. So when exposed to light, some substances will emit light energy. And if this process happens in the presence of oxygen, as I've already mentioned, that oxygen will absorb some of the light that is produced. And the photosensitive material that is used to detect the amount of light that is left will detect light that is inversely proportional to the number of oxygen molecules in the sample. So as a result of this, if you want to measure concentration using these types of sensors, the less light you get from the photosensitive material, the less light you detect, the more oxygen there is in that fluid sample. So an advantage of these optical sensors is that they require no calibration. They are long-lasting than the electrochemical sensors, and they are also durable. Now, the last type of sensor we're going to talk about is the laser oxygen sensor. And the makeup of this laser oxygen sensor is a tunable diode laser, and they rely on spectral analysis. So a laser beam at the wavelength of oxygen is directed through a gas sample to a photodetector. So we have a principle called atomic absorption spectroscopy, which the first basic principle of this theory, the first basic principle of this theory states that when light of a particular wavelength is exposed to particles of the same wavelength, that light is absorbed. So using this theory, you can be able to sense oxygen in the sense that if the light detector detects less oxygen, then there is more oxygen in that fluid sample. So you can determine the concentration using that principle. And an advantage of this laser oxygen sensor is that they have a quick response time, and they are very accurate, up to tens of 1% of oxygen. And they don't require any calibration at all, as well as they have a long life. The only disadvantage of these laser oxygen sensors is that they are very expensive. With that, I am done with the topic of interest. Thank you very much for your attention. Over to you, Sharon.
Thank you very much, Kevin, for that explanation. Any questions or comments on the explanation Kevin has talked about oxygen sensors? Okay, Maui, do you have something?
Yes, so I actually created a poll relating to the topic that Kelvin just presented to us. So I'll be launching that poll, and then we'll see the response from the audience. So the poll says, did you know that oxygen monitoring systems in oxygen analyzers and concentrators come in different types? So prior to this, I only knew about two, the ultrasonic and the electrochemical. I didn't know that there were different other oxygen sensing devices. So thank you very much, Kelvin, for the topic. We've learned more things here. So the votes are still coming in, so I'll still leave it open, and then we see the responses from the rest of the audience. Okay, so it seems most of us knew that there were different types. So maybe Sharon, we can also just hear from the audience what type of sensors they have ever come across. All right, thank you very much. Back to you.
Thank you very much, Maui. I didn't know we had so many types of oxygen sensors. I also knew only of two. So maybe from the audience, you'd like to share with us the type of sensors you knew? Anybody? Okay, no one would like to share. Okay, so now we move on to our next question. And it says, hello, I'm a biomedical technician from Manza district. When COVID-19 pandemic was at its peak, we received oxygen cylinders. We used them on our patients and now they are empty. Is it okay if we refill the oxygen cylinders using oxygen concentrators so that we can have enough oxygen for our patients? I'll ask Masofa to answer this question.
Thank you, Sharon. An oxygen concentrator separates oxygen from air and concentrates the oxygen to 90%, between 90% and 95% purity. There is no refilling or topping up the required for an oxygen concentrator, and it requires a power supply to operate. An oxygen cylinder is an oxygen tank that stores pressurized oxygen, and capacity depends on the size of the oxygen cylinder. For example, standard D size oxygen cylinder. You cannot directly refill an oxygen cylinder using oxygen from oxygen concentrator because the oxygen will not be pressurized. Most cylinders used in hospitals are large and they have a higher capacity up to 200 psi, and it's not possible to compress that amount of oxygen in a cylinder using an oxygen concentrator. Basically, in a hospital setting, you cannot use an oxygen concentrator to refill an oxygen cylinder unless you have a special equipment that will help you to compress the oxygen from the oxygen concentrator at a higher pressure to the cylinder. Home fill oxygen devices or oxygen transfill systems are popularly known as oxygen refill systems. They are portable oxygen refill devices that are used at home to fill empty oxygen tanks. By using oxygen concentrator technology, and concentrated oxygen is extracted from room air to oxygen refill machine. This gives the user an unlimited refill of oxygen. The concentrated air is then pressurized by a refill system to fill the oxygen cylinder. You can refill oxygen tanks in the following manner. Place an oxygen refill machine on top of an oxygen concentrator and connect them to each other. Plug them into an electrical socket and press the power button to turn on the machine, just like it's shown on the picture there. And then connect your oxygen tank and cylinder to the refill machine. Make sure that the oxygen conserver or regulator on the tank is turned off. If you are not using a conserver or regulator to fill the oxygen cylinder, verify that the cylinder valve is closed to ensure proper filling. Remove any protective caps from the oxygen tank. When not in use, replace the protective caps to prevent dust buildup. Gently pair the cylinder fill port of the refill machine with the cylinder. You will hear an audible click when the cylinder is secured to the oxygen compressor. Press the fill button to begin refilling your oxygen tank. The refilling might take some time depending on the size of your cylinder. You will be indicated when the tank is full. Most machines automatically shut off when the canister is full. Turn off the power button and release the cylinder from the oxygen refill system. This method can only be used at home to refill portable oxygen cylinders. So basically you cannot use oxygen concentrators to refill large oxygen cylinder, e.g. 200 psi pressure. An oxygen concentrator delivers oxygen of 5 to 7 psi pressure. That means the refilling will just depend on the size of the cylinder. In hospitals, you will find large oxygen cylinders that cannot be refilled using oxygen concentrators. So you cannot use oxygen concentrators to refill the cylinders because of the size. Thank you.
Thank you very much, Mustafa, for that explanation. Any additional comments from the technicians or questions from the audience? Okay, if we have no comments and questions, if we look at our time is up. So I would like to thank you all for joining us for this week's Concentrator Talk. For our new members, please share with us your contact details in the chat so that we can add you to our emailing list. So before I conclude, Maui, do you have any announcements?
No, nothing from me, Sharon. Maybe one thing. So we're working on our next video for the Oxygen Alliance. So please be on the lookout for that. Once it's been posted on our YouTube channel, we will share the link with everyone. And if you haven't had a look at the other videos that we have made, you can also have a look at those from our YouTube channel. Thank you, Sharon.
All right, thank you very much. So if you have any questions for us concerning oxygen concentrators, maintenance or use or any issues, please email to us via our email info@oxygenalliance.org and we'll do our best to answer that. And please visit our website, as Maui has said, www.oxygenalliance.org, where you find all the recordings of the previous concentrator talks, even the oxygen talks, you find them there. Any special topic of interest that we did previously, you even find the videos there. Also, please check out our YouTube channel. You can see the videos and please subscribe every time you visit. So until next week, it's goodbye.